Astronomers detect a mysterious blast of radio waves that took 8 billion years to reach the Earth.
Has released the first images taken by the James Webb Space Telescope.
The pictures are unlike anything we've ever seen before.
For the first time ever, the Hubble Space Telescope and the James Webb Space Telescope are both locked onto the same interstellar visitor, 3I Atlas. Not one, but two of humanity's most powerful eyes in space, capturing it in invisible ultraviolet and deep infrared light. Two perspectives, two sets of instruments, one mysterious target. Hubble, orbiting just above Earth, is mapping the comet's coma, that huge ghostly cloud of gas and dust spilling from its core. James Webb, sitting a million miles away, is breaking down its spectrum like a cosmic crime scene, reading the chemical fingerprints hidden in its light. This has never happened before. No other object from beyond our solar system has ever been studied in this kind of tag-team mission. Normally, Hubble and Webb don't share a target. Their time is too precious, their missions too different. But 3I Atlas? It's no ordinary visitor. On July 21, 2025, Hubble delivered the sharpest image yet, a faint, eerie envelope stretching tens of thousands of kilometers, masking a nucleus only a few kilometers wide. From these shots, scientists estimate it's shedding between 6 and 60 kilograms of material every second. That's like watching a full-size car vanish into space every single minute. Meanwhile, Webb is peering deeper, seeing what Hubble simply can't. Its infrared vision has confirmed frozen water ice, carbon-rich dust, silicates, and complex organic molecules. Ancient compounds, possibly locked in place for over 7 billion years. For the first time, we're getting a complete spectrum profile of an alien object, its makeup, its activity, its behavior, all recorded in breathtaking detail. When scientists combined the first Hubble and Webb data, something strange popped out. Not one huge anomaly, but a chain of small oddities that together just don't add up. The first red flag came from the coma. Normally, a comet's dust and gas get blasted away from the sun, forming a tail that always points in the opposite direction. But 3I Atlas? Part of its dust stream is actually angled toward the sun. That's rare, and it hints the particles might be heavier, chunkier than normal comet dust, making them harder for sunlight to push. Something in its makeup is fighting back. Then Webb's spectrum revealed water ice, just like you'd expect, but also an intricate mix of carbon-rich compounds and silicates. None of that is shocking, except for their condition. They look almost untouched, as if they've been shielded from heat and radiation for billions of years. Some of these molecules might even be older than our sun itself. The imaging deepens the mystery. The coma is way brighter than predicted, but the nucleus is smaller than expected for such intense activity. That mismatch has scientists asking, is this brightness really just sunlight bouncing off dust? Or is there some unknown process making it glow? And then there's the orbit. While it's moving retrograde, opposite to the planets, it's gliding just 5 degrees off the ecliptic plane. That's unusual. Most interstellar travelers dive in at steep angles, the way you'd expect from random galactic drift. But not this one. This one's flying low and close to our cosmic highway. But 3I Atlas isn't swooping in at some random angle. It's almost perfectly lined up with the same plane our planets travel on, as if it slipped in through the very corridor we use to send probes toward deep space. Some shrug it off as coincidence, but others, like Avi Loeb, point out that its sequence of planetary flybys, Venus, Mars, Jupiter, has only about a 1 in 20,000 chance of happening by accident. That doesn't prove it was intentional, but it sure makes you wonder. Could the strange tail angle, the untouched ancient material, the blindingly bright yet tiny core, and the razor-precise path all just be random? Or are we looking at the fingerprints of something we've never encountered? Maybe an unknown natural process, or something deliberately designed? Right now, the Hubble and Webb teams are still gathering every bit of data they can. But one thing's certain, 3I Atlas is not playing by comet rules. Every finding sparks a new question, and every answer just cracks open two more mysteries. And the clock is ticking. This object is screaming through space at nearly 60 kilometers per second, and in just weeks it will disappear behind the sun from our view. For Earth-based telescopes, that means total blackout. For Hubble, the sun's glare will be blinding. Even Webb, parked a million miles away, will have to pull back to avoid frying its optics. The worst part? That blackout comes right at perihelion, the closest pass to the sun, when the heat will rip into its frozen layers, possibly triggering violent bursts of fresh material from deep inside. Those outbursts could reveal minerals older than our sun, but we might not see it happen. The universe loves irony. The moment of greatest discovery could also be the moment we're forced to look away. But there are other eyes in the solar system, not aimed at 3I Atlas right now, but close enough to swing into action. The European Space Agency's JUICE probe, en route to Jupiter's icy moons, will pass within just 0.3 astronomical units of the comet during part of its journey. Around the same time, NASA's Psyche spacecraft, headed for a metal-rich asteroid, will cruise at a similar range. At those distances, even a modest camera could capture details impossible to see from Earth. The catch? Redirecting them means burning precious fuel meant for their primary missions, rewriting navigation plans, and convincing mission teams to gamble resources on an object that poses no official threat. In deep space, every kilogram of propellant is survival. Every course correction is a calculated risk. Then there's the boldest idea of all, using NASA's Juno spacecraft, currently orbiting Jupiter, to pull off a dramatic flyby of 3E Atlas in early 2026. Avi Loeb and his collaborators propose slingshotting Juno around Jupiter for a massive speed boost, enough to bring it into range as the comet heads back toward the outer solar system. On paper, the math checks out. In reality, Juno's main engine is damaged, and its remaining fuel might not be enough for such a razor-precise maneuver. Some call it a brilliant use of a spacecraft already in position. Others call it reckless fantasy. But everyone agrees. If it could be pulled off, it would be our first close-up view of an interstellar visitor. That's why the urgency is building. This isn't just another comet. It's a fragment from another star system, a messenger from a place we may never reach. And if it holds secrets we've never seen, this could be our only chance to learn them. In just months, it will slip away. Its coma will dim. Its spectrum will fade into the background noise of space. And it will become just another moving speck, shrinking into nothing. Once gone, there's no chasing it. No second chance. This is a race against celestial mechanics, against the sun itself, and against the cold indifference of the universe. Soon, 3I Atlas will vanish behind the sun, and when it comes back into view, it'll already be leaving us, fainter and faster than before. As the blackout window looms, astronomers are scrambling to squeeze every last frame, every last spectrum, out of 3I Atlas before it's gone. They're coordinating across continents, from Chile's Atacama Desert to Hawaii's Mauna Kea, timing observations to the millisecond. The goal? To lock in baseline data that will still mean something months later, when the comet is nothing but a faint memory. Already, subtle changes are being logged, fluctuations in brightness that don't match the usual warming and cooling cycle, shifts in the dust jets that seem almost patterned. Could it just be the chaotic spin of a fractured nucleus? Or is there some deeper mechanism at play, one we've never documented in any comet before? Adding to the tension, deep sky surveys like Pan-STARRS and Vera Rubin Observatory are being tapped to scan the regions ahead of 3I Atlas's path, just in case it isn't alone. A companion object, even a tiny one, could blow the door wide open on how interstellar bodies travel. If the blackout hits before we find answers, the trail could go cold forever. And that's what gnaws at the scientists most, not the possibility of danger, but the possibility of never knowing. In science, uncertainty is worse than bad news. And right now, 3i Atlas is writing uncertainty across the sky in bold strokes. But there's one more twist: radar. Normally, comets are too small and distant for planetary radar systems to track in detail. But if 3i Atlas passes close enough to Earth's orbital path before perihelion, powerful arrays like Goldstone or the Green Bank telescope could ping it with radio waves, mapping its shape in echoes. The odds are slim, but if it works, we could get a rough 3D profile, the kind of intel that would settle debates about whether its form is natural or something else entirely. The window for this is razor thin, days, maybe hours, depending on its speed and solar interference. And even if the geometry works out, there's no guarantee the return signal will be strong enough to decode. It's the observational equivalent of catching a whispered secret across a crowded room. Meanwhile, theorists are already sketching models to explain the anomalies, from bizarre cryovolcanic cycles to exotic mineral compositions that barely exist in our own solar system. A few even toy with Avi Loeb's wilder proposition that 3i Atlas might not be a comet at all, but a fragment of engineered material adrift for eons. Whatever it is, once it rounds the sun and shoots back into the darkness, it'll be gone for good. The choice is brutal: take risks now, burn the resources, or watch history slip out of reach, knowing you'll never get another shot. As the debate rages, data keeps rolling in, and 3i Atlas keeps refusing to play by the rules. Fresh images show asymmetrical jets of dust bursting from its surface, sometimes from the shaded side where sunlight shouldn't even reach. That's not impossible, but it's weird. It hints at deep internal heat sources or buried volatile pockets erupting like geysers in the dark. Spectral readings are no less baffling. Minute fluctuations in the chemical signatures hint that the outer layers might be peeling away, exposing material that hasn't touched space in billions of years. And each new reading makes the clock feel heavier. Every hour that passes means the comet is closer to the sun, closer to disappearing into that blinding wall of light. In back rooms and video calls, mission planners are running cost-benefit equations like war games. Some argue for aggressive maneuvers, risking fuel, risking hardware, because history won't remember caution. Others say the data we already have is priceless enough, better to protect the mission still in play. But 3i Atlas doesn't care about our arguments. It's moving on its own schedule, following a path carved long before humans ever looked up. And soon, it will leave our skies entirely, without waiting for us to decide. Maybe it's just a shard of ice and dust from a forgotten star system. Or maybe it's something stranger, a relic, a fragment, a messenger that's been drifting through the void for longer than life has existed on Earth. Right now, no one can say for sure. What's certain is this: 3i Atlas has given us a chance that may not come again for centuries. A chance to look directly at something born in another corner of the galaxy, to study its form, its chemistry, its behavior, before it's swallowed back into the endless dark. But that chance is slipping. In a matter of weeks, the sun will hide it from us, and when it emerges again, it'll already be fleeing outward, faster and fainter, beyond the reach of even our most powerful instruments. By then, the mystery will harden into legend, a puzzle with too many missing pieces. And we'll be left wondering whether we stood on the edge of one of the greatest discoveries in human history, or simply watched a cosmic stranger pass us by. If you want more deep dive breakdowns into space's biggest mysteries, make sure you subscribe, hit that like button, share this with your friends, and drop a comment with your theories on 3i Atlas, because this story is far from over. A fleeting guest from another star system, drifting silently through our own before vanishing forever. What Hubble and Webb are capturing right now, the images, the spectra, the raw numbers, will be the record we hold for generations. Every pixel, every spike on a graph will be pored over for decades. And yet, even with all this, the truth might still slip through our fingers. Maybe it's exactly what the cautious voices claim. Just a comet. Ancient, yes. From far away, yes. But still, nothing more than ice and rock obeying the laws of physics and the blind roll of cosmic dice. Or maybe, hidden in the patterns of light and shadow is something we haven't yet learned to see. A detail too subtle for the untrained eye. A signal buried in the dust. A path that was never random to begin with. If that's true, we might not realize it today. It could take years, even decades, before someone spots the anomaly that changes everything. And by then, it'll be too late to look again. Out here, there's no rewind. It's humbling, and just a little terrifying. A fragment of another world is here, right now, and we're throwing everything we've got at it, not just to understand it, but to understand ourselves. One day, another interstellar traveler will arrive. Maybe in years, maybe in centuries. But it will happen. And when it does, we'll remember this moment. The first time humanity's two sharpest eyes worked together. Not on some far-off galaxy, but on a single speck racing through our own backyard. So, if you want to be here when that next fragment arrives, subscribe, hit like, share this video, and drop your theories in the comments, because the sky was never empty. And now, we're finally starting to see the truth.